Each year, on average, 100 firefighters die in the line of duty, and approximately 80,000 are injured. The number of fires has decreased in recent decades, but the number of line-of-duty deaths and injuries among firefighters has remained constant and unacceptably high. The U.S. Bureau of Labor Statistics reported that between 2003 and 2007, volunteer firefighters had the highest number of fatal injuries of any occupation. Among volunteer workers who were fatally injured while performing their duties, almost 1/3 were volunteer firefighters. Why do firefighters, volunteer or career, have a high risk of injury and death? What can be done to reduce their risk? In 2005, Congress appropriated funding to the Assistance to Firefighters Grants to engage U.S. universities and other research organizations to find ways to reduce firefighter deaths and injuries. Through the AFG's Fire Prevention and Safety Grants program, more than 60 firefighter safety research and development grants have been awarded to improve firefighter safety, health, and well-being. These grants are based on a partnership between science and the fire service. Firefighter and industry partners work with researchers and engineers on these studies to develop new firefighting technologies, evaluate risk behaviors, and test ways to move new safety and health information into firefighter programs and practices. Firefighters are involved in each phase of these research grants, from early project planning and active participation in the study to facilitating the transfer of research results and information into everyday practice. Firefighter Safety Research and Development Awards are made in 5 main areas of study. First, behavioral, clinical, and social science research, such as projects to prevent heart disease or hearing loss, both of which are prevalent among firefighters. Second, database systems research, which includes projects to gather injury data on firefighters. Third, technology and product development studies to improve the performance of firefighters' personal protective gear or to develop new technologies. Fourth, dissemination and implementation of effective programs and products, which involve research on the most effective methods for teaching firefighters new tactics. And fifth, in fiscal year 2011, the research and development category expanded to include preliminary studies research projects. Preliminary studies will help to determine whether sufficient evidence exists on a particular topic to warrant conducting larger research efforts. Every year, thousands of fires are reported in high-rise buildings. Such fires are among the most technically complex and deadly operations for firefighters and the public. In 1998, 3 New York City firefighters responded to a fire on the top floor of a high-rise apartment building and followed the procedures they had been trained to use for this type of fire. When a 20-mile-per-hour wind gust suddenly blew in through a broken window on the upwind side of the building, it drove the flames through the corridor, engulfing the firefighters. There was no time for escape. All 3 firefighters died. No one had anticipated that the breaking of a single window could rapidly transform the building corridor into a furnace. The AFG's Fire Prevention and Safety Grant Program provided a 2006 grant to the Polytechnic Institute of New York University to study wind-driven high-rise fires and to help develop firefighting procedures that would improve the safety of both firefighters and civilians by controlling smoke and heat. Polytechnic partnered with the Fire Department of New York City and the National Institute of Standards and Technology on the study. Wind experiments were carried out, and the information derived from the results were used to conduct a series of live, controlled burn experiments in an abandoned high-rise building. The main goal of the experiments was to test 3 different tools for fighting high-rise fires under wind-driven conditions: positive pressure ventilation fans, or PPV fans, thermal fire blankets, and specially designed high-rise or mobile nozzles. The tests would help researchers and firefighters to better understand how to control the flow of fire and smoke while operating at high-rise fires. The experiments proved that all 3 tools and tactics were effective at controlling wind-driven conditions. but firefighters needed to understand the optimal uses for these tools under varying weather conditions and different building geometrics. To address this need, researchers developed computerized simulations that enabled them to test the new tools in a variety of conditions. They found that the results of the burn experiments and the computerized simulations were in close agreement and proved the efficacy of the firefighting tools to improve safety in high-rise firefighting. When FDNY firefighters used the new firefighting tools and tactics during rescue and attack operations in actual fires, they found that the tools improved the safety of firefighters, sometimes dramatically. FDNY officials then revised their standard operating procedures to incorporate the new high-rise firefighting tools and tactics. In 2010, more than 11,000 New York firefighters received training in the new procedures. Fire departments in other major cities had followed the progress and results of this research and decided to also adopt these new high-rise firefighting strategies.
The FDNY worked with scientists and engineers to tackle problems of firefighter safety. AFG's R&D funding enabled this research, and the FDNY implemented the results. We trained our firefighters on the new firefighting procedures, and these changes already have been put into practice and have saved lives. The partnership between science and the fire service demonstrated in this project has the potential to revolutionize firefighting practice for safer and more effective operations. On behalf of the 12,000 FDNY firefighters, I want to thank everyone involved in this important research.
Just as important as the development of new technologies is research focused on the health and wellness of individual firefighters. Heart attacks and other cardiovascular events are the leading cause of line-of-duty deaths among firefighters. Dr. Stefanos Kales, Associate Professor of Medicine at Harvard Medical School, is currently leading a team of researchers to identify the key factors behind cardiovascular events among firefighters and develop strategies to help prevent them. Although the research is still in progress, it has already yielded important findings.
We already know that in the fire service, almost half of line-of-duty deaths or on-duty deaths are due to heart attacks and other cardiovascular events. We also know that these events are not random. Many are preventable. And sadly, when we investigate these events, we often find that the firefighter who has fallen victim had underlying heart disease that was either known or simply had been previously undetected. This situation has to change. Our aim is to identify key risk factors that could lead to preventive strategies to decreasing firefighters' risks and helping firefighters to stay healthy.
The Harvard Research Project, which involves 1,000 firefighters, is analyzing data on exercise and fitness capacity among firefighters and the levels at which firefighters are more likely to be at risk of heart attack. Researchers established baseline measures for various physical activities using metabolic equivalent tasks, or METs. Walking qualified as about 3 METs, jogging is about 7, and running fast is 18 METs. Firefighting is physically demanding and involves activities such as climbing ladders, advancing charged hose lines, and rescuing victims, all while wearing heavy protective gear and equipment. Therefore, firefighting activities were estimated at 12 METs. However, most doctors who treat firefighters with heart disease recommend the same treatments that they would for an average person who is inactive. Based on the information that was just reviewed, that approach may not be in the best interest of an active firefighter. These examples demonstrate the far-reaching impact that research and development grants can have on firefighter safety, health, and wellness. Just as critical as the actual research is the effective dissemination of the research results throughout the fire service so that departments can implement policies, programs, and training that are based on the knowledge produced by the research. This is the final step in transferring the research to everyday practice. Whether you are a scientist or a firefighter, we invite you to consider getting involved in a research and development partnership to improve the safety, health, and well-being of our nation's firefighters. Researchers with many different specialties can contribute to the research and development program. If you are a firefighter, your department may want to consider participating as a partner on a research project. Studies throughout the country are benefiting already from the participation of thousands of firefighters like you. You can find information about applying for a research and development grant on the AFG website at www.fema.gov/firegrants. While on the website, sign up for the AFG newsletter so that you receive grant program announcements by email, or call the AFG Help Desk at 1-866-274-0960 to speak to a fire program specialist.